Continuing on in section 3.8 here, we have unions and intersections of sets. I can find the unions and intersections of sets. Big ideas. Given two or more sets, the set of elements belonging to at least one set is the union of the set. Given two or more sets, the set of elements belonging to all of the sets is the intersection of the sets. So in example 3 here, we're going to use Venn diagrams. Three friends are going camping. The items in each of their backpacks on page 216 form a set. Which items do all three friends have in common? I put these picture of the backpacks here, but if you look on page 216 in your book, it's a lot better picture there. So the first thing I'm going to do is I'm going to come up with a set for each. So yellow has a flashlight, water, a map, hat, sunglasses, and a pan. So when I just list all these out, remember that's roster form. We just list them out. In the blue backpack, I have a water, map, camera, hat, and a first aid kit. And in my red backpack, I have a map, rope, hat, first aid kit, water, and pan. So there's the sets for each backpack. We're going to use a Venn diagram to figure out what all three friends have in common. And we could do that here from our roster forms as well, but we're going to need Venn diagrams here in a little bit, so I'm going to go with those. For Venn diagrams, we need one circle for each set. So I need one circle for yellow, and these circles are going to be intersecting. One circle for blue, and one circle for red. And these represent my backpacks. Keep in mind that everything inside the red circle is part of the red. Everything inside of the blue circle is part of the blue. And everything inside of the yellow circle is in the yellow. So in the middle section here, for example, we have things that are both all red, yellow, and blue. This section here is just blue and yellow. This section is red and yellow. So those are some options we have for things where they overlap. And so we're only going to write each item one time, exactly once, in the spot that makes it true for each set. So I only have a flashlight in yellow, which means flashlight goes in just the part of my Venn diagram that's yellow. I have a water in yellow and blue and red. So I put water in the middle where they all overlap. I have a map in yellow, blue, and red. So again, I put map in the middle where they all overlap. I have hat, hat, hat. So again, hat goes in the middle where they all overlap. That's a part of my red circle and my blue circle and my yellow circle. Sunglasses, I just have one pair in yellow. And pan I have just in yellow and red. I have a camera, just one in blue. I have a first aid kit in blue and in red. So I put it in the section that's in both the blue circle and the red circle. And then rope I have just in the red. So if I look here, keep in mind each circle has to have everything in it. So in my yellow circle, I need to have a flashlight, water, map, hat, sunglasses, and pan. In my blue circle, I need to have water, map, camera, hat, first aid kit. And in my red circle, I need to have map, rope, hat, first aid kit, and pan. So everything's accounted for where it needs to be to have it listed exactly one time and still be included in the original sets. So here we want the set of all the things that are included in all of them. That's this middle part. So my set's going to be water, map, and hat. Now feel free to pause here and give this a try if you'd like. Again, the first thing I'm going to do is list these out in roster form. One of the first 5 letters of the English alphabet. So I'm looking for A, B, C, D, or E. For set B, I want anything as long as it's a vowel. Any letter as long as it's a vowel. So here, A, E, I, O, U. Sometimes Y. If you put Y, that's okay. If you don't, that's okay. And C is a letter in the word vegetable. So I have V, E, G. Keep in mind I already used E, so I only list it once. T, A, B, L, and again I already have E here. I only list it once. So I have 3 sets, so I'm going to make 3 circles again. And they're going to overlap. Here I'm going to label them A, B, and C. And the last one I just labeled them by color, but here we'll go with the actual set names. So I look, A. A is in all 3 things, so it goes in the middle. B, B. I have B in A and C, so I go where A and C overlap. C, I just have an A. D is just an A. And E is in all 3, so it goes in the middle with A, where all 3 circles overlap. I is just in B. O is just in B. And U is just in B. V is just in C. G is just in C. T is just in C. L is just in C. Again, keep in mind, we want to make sure everything is accounted for exactly once. So A, B, C, D, E. A, E, I, O, U. V, E, G, E, T, A, B, L, E. So again, every letter is accounted for exactly once in the spot that makes it true. So B, for example, is in both C and A. Perfect, we have it marked in C and A. So we want to know which letters are in all 3 sets. Again, that's going to be the middle part here. That's part of all 3 colors, A, B, and C. So A and E is a set that's included in all 3 sets. In example 4, we're going to use Venn diagrams to show the number of elements. So of 500 commuters polled, some drive to work, some take public transportation, and some do both. So the things we're comparing here are people who drive to work to people who take public transportation. The both part here is this. Okay, it's the part where they overlap, the part in the middle. That's both. So 200 commuters drive to work. That's this entire circle. This entire circle is the people who drive, and that's 200 people. Keep in mind we have 500 total. 125 use both, so that 125 goes here. We want to know how many commuters take public transportation. So we're looking for this entire yellow thing. We want to know everybody who takes public transportation. So if I know that 200 people total drive, and this part's 125, then my missing part plus 125 has to equal 200. So I can take 200 minus 125, and that gives me how many are left. 75 people just drive to work, because 75 plus 125 gives me that 200 for that entire circle. We have two pieces to that circle, people who just drive and people who do both, and combined they make the 200 that we need. Now, remember that we have 500 total people. So all three of these have to add up to 500. Everybody has to be accounted for. So 500 minus the part that I know, 200, is going to give me 300. So people who just take public transportation are 300. Okay, because 75 plus 125 plus 300 gives me 500. We don't want to know how many people just take public transit, though. We want to know how many take public transportation total. That's this entire circle. So we add these two up and get 425 people. Okay, again, we want everybody who takes it total, 425 people. Now, feel free to pause here and give this a try if you'd like. Of 30 students in student government, a total of 20 are honor students and 9 are officers and honor students. So what that's telling me is that we have honor students and then we have officers. Some of them are honor students as well. That's going to be our overlap. So I'm going to have honor students and officers. Okay, a total of 20 are honor students, 30 total students, total of 20 are honor students. That means this entire circle is 20 kids. 9 are officers and honor students. So that goes in the middle, that's my both. Which means if this entire circle here is 20, and I have 9 in one part, I have to have 11 in the other. I have a total of 30 kids, 20 of them are honor students, which means I have 10 left here. Now, what we want to know is how many are officers but not honor students. So we want officers, but we don't want honor students. So we're staying just on this side here, which gives us just the 10. Okay, total of 20 means we added up all the honor students and got 20. Okay, if they're not an honor student, they're just an officer. Out of the 30 kids, that means there's 10. And that's what we're looking for. Officers, but not honor students. This portion right here, and we get 10. Remember that and inequalities form intersections, and or inequalities form unions. So here, the first thing we're going to do is we're going to solve this. And then we're going to write it as the union or intersection of two sets. When we have absolute value, whatever's inside could have been less than 3. Okay, we take the absolute value of it though. So whatever's inside could have been the opposite. Whatever's inside could have gone to -3. Keep in mind though, if we flip our number, we have to flip our inequality. If we change our number, we change our inequality. And because I have a less than here, that makes this an and inequality. Solve by adding or subtracting first, then divide. And if you weren't sure that it was an and before, you can check here. Are there any numbers that are less than 2 and greater than -1? You bet, numbers like 0 and 1. So, because it's an and, that means it's an intersection, and we're going to use this symbol here. In order to write this as an intersection or union of two sets, that's a spoiler alert right there that we're going to have two different things to compare. I switch my and to my intersection symbol, and I just put my inequalities in set builder notation like we did in section 3.5. So I keep my inequality, and I just say, hey, it's a set of any number such that x is less than 2, intersected with, or and, the set of any number as long as x is less than -1. Close our brackets to show it's a set. So again, to put an inequality in set builder notation, I just add my curly brackets and my x such that. And I'll continue in another example, or another video.